So our rules don't change here. Here's a new function. It's already factored, so step one's already done. Notice right away that two of the binomials will cancel. That means there'll be a removal, a little hole in the graph, right? So again, it starts with setting, since step one's done, it starts up with setting the domain, which is all real, except -1, all right, or these two binomials. And I suppose it's 7/3, right? And I suppose if I wanted to factor, guys, I can factor this. I could bring out the 5. And I can bring out the 3. And then it really becomes obvious that 7/3 is one of the vertical asymptotes. A 0 here, do you guys agree? There is only one 0. -3/5, because once -1 becomes an asymptote, it can't be a 0. Period. And then I still like to find the y-intercept f of 0, and I go back to the original blue function usually to do this. I plug in 0, and you think about it. If I plug in 0, this goes away, this goes away, this goes away, this goes away. I think it's -3/7. All right. And again, it's just an easy thing to do to help me set my graph. Because I put in 0 first. I find the y-intercept if I know x is 0. Find the y-intercept. All right. To me, that's step 2 every time. Now I want to find the horizontal. What number does this approach as you get very, very, very big? All right? And this is where our skill. Now there are some rules, there's some shortcuts, but I'm not going to go through those yet. There are, and then most math teachers will just say, "Oh, here's our rule, apply it." But the odds you remembering that rule are not real high. Does everybody agree? If I start putting in a very big number, like 1,000,000 up in the middle, you agree we don't care about the +3. And if you put in a really big number, what happens to the x+1? It cancels. You guys agree? So really, this function this time goes to this for a very big number of x. But do we care about the +3 if it's really big? No. Do we care about the -7? No. So what's it approach? It approaches 5/3. And there's some notation here. You can say the limit as x approaches infinity, as x gets really, really, really big, of the function, as you get really far to the right, what does it approach? It approaches 5/3. This is calculus. Again, we're in pre-calculus. Good practice. All right, so we found now the horizontal asymptote. Okay? From the blue again, we know there's a hole at -1. Right? We knew that from the get-go, and we know it's an asymptote at 7/3. So I'm going to start graphing. And I'm going to make my own graph, because if I was doing this in a homework problem, I wouldn't bother getting graph paper. I'd label my y. I would label my x. I know that -1 has a vertical asymptote. There it is. And I know, oh, no it doesn't. I just said this, 2 seconds. 7/3 has a vertical asymptote. And I know -1 has a hole, okay? And I don't know if it's above the axis right now or below, but I'm just going to put a hole here, which I might have to move, up or down, right? But at -1, there's a hole. I know there's a 0 at -3/5. And I know f of 0 is -3/7. Now, and I know the horizontal asymptote is at +5/3. You guys get pretty smart. When you look at this graph, I bet you might have an idea where it's at right now. Because if these cancel, is this exactly like a lot of functions we were doing before then? Once we know the hole's there, we can consider those canceled. We know this is going to be our reciprocal function, right? Which we know is either this or this. But we're pretty sure right now it can't be the one I just drew, based just on the 3 points I plotted. All right? So actually, for me, because I have so much experience, I can sketch this right now. And actually, you guys might be able to too. So we're going to make the sign table stuff. All right? A sign table always leads to the right answer. So you got x, you got x plus 3/5, you got x minus 7/3, and I have f of x. Again, I dropped the two positive coefficients, 5 and 3. I don't need to include x plus 1 in my sign table, because they cancel, and the sign will be the same. Two positive are positive, two negative are positive. My points are -1 and 7/3. -1 is an asymptote, so it's an undy. 7/3 is my 0. Here we go. Oh, I got it backwards. Oh, I gotta get -3/5. Yes, I'm sorry. You're right. I missed one. I looked at the wrong number. So -3/5 is here. That's a 0. And then, right, 7/3 is the undefined. Okay. So we got 3 zones. Again, gigantic negative number. Negative, negative, positive. So over here on our graph, up here, it'll be positive. All right, we can see coming up, it's going to be on the lower side of the horizontal axis. All right. If I go back over here, in between, oh crap. Negative, negative, positive. So it's still positive here, and that makes sense to us because the hole doesn't do anything, right? It's just there. It's positive on both sides would be removable right here on this hole at 1, -1. All right, in between here, I bet you it goes negative. In fact, we know it's negative from the y-intercept. At 0, it's positive, negative, negative. Result, and when it's really big and positive, it's positive, positive, positive. So it's negative here, and it's positive up here. So the only place it's negative is between the 0 and the asymptote. It's only negative in here. Right? It's positive everywhere else. All right? I move all these signs out. I know at 1 there's a big old removable. All right? I know up here it's positive. And again, I just sketched. Now this time it's order 2 over order 2. Think about it. You guys agree? It's x squared over x squared if you multiply by numbers. But it looks, because we had a removable, it looks the same. A removable hole here at -1. All right? And again, this just takes lots of practice. Get used to graphing rational functions.